Hello everyone. Today I will talking about the first lesson about attempts of elements classification. Okay, but before that I will explain the meaning of atomic number and atomic weight. Okay, because it's very important in our lesson. Okay, you studied in the last year the symbol of element, okay, like sodium Na. So this is the symbol of sodium atom, and here write 11, so 11 here expressed to atomic number, and it is written below the symbol in the left side, and here 23 expressed to atomic weight, and it is written above the symbol on the left side. Okay, let's back to our lesson. Attempts of elements classification. Okay, there are many elements on the Earth's crust. So the scientists tried to classify these elements. So the question here, why do scientists classify elements? So the answer here, one, to facilitate their study. The second one, to find the relation between elements and their chemical and physical properties. Okay? So in this lesson, we will study many subjects related to the attempts to classify the elements, such as Mendeleev's periodic table, Moseley's periodic table, modern periodic table, and how to calculate the atomic number in the modern periodic table, and how to locate the element in the modern periodic table. Okay. The first attempt by scientist Mendeleev. Okay, Mendeleev's periodic table. It's the first real periodic table. It's the first real periodic table for classify element. Okay, at this time, only 67 elements had discovered. Okay, so how Mendeleev classified element? Okay, by these steps. The first step, okay, Mendeleev prepared, okay, 67 cards. Each card is represented an element, okay, and then recorder in each element the name of element, the atomic weights, and some properties such as melting point, boiling point, the number of oxide. Okay, so as you can see, these the model of cards. Okay. So the second one, he arranged these elements in vertical columns, which were no later groups. The second step, he arranged the element in ascending order according to their atomic weights from left side to right side in horizontal rows, which were no later periods. Okay. Finally, he arranged elements for each main group into two subgroups, group A and group B. So this is why, due to the difference in their atomic weights. Okay, so let's study the Mendeleev discovered that. So the atomic weights of elements increases on moving from left side to right side in horizontal rows. Okay, the second one, the properties of elements were repeated periodically by the beginning of each new period. Okay. Okay, let's study the advantages of Mendeleev's table. The first one, Mendeleev, he left gaps or empty cells. Mendeleev left gaps or empty cells in his table. So this is why, because he predicted the discovery of new element. The second one, Mendeleev, he corrected the values of some of elements. He corrected the values of atomic weights of some elements which were not discovered yet. Okay. So he determines the values of atomic weights of some elements which were not discovered yet. Finally, he corrected the atomic weights of some elements which were estimated wrongly. Okay? Before I explain the disadvantages of Mendeleev's table, I will explain the meaning of isotopes. So, what is the meaning of isotopes? Isotopes means many forms of elements, and the many forms of elements it have the same atomic number but different in atomic weights. For example, here this is isotopes of hydrogen. Okay, so this is many forms of hydrogen but have the same atomic number but different in atomic weights. Okay. Disadvantages of Mendeleev's table. Okay, first one, he had to make disorder in the arrangement in the ascending order of atomic weights of some elements. This is why, because he put them in groups that suit their properties. Two, he had to deal with isotopes of one element as a different element due to the difference in their atomic weights. So this is the model of Mendeleev's periodic table. Okay, look at here the atomic weights, 122. The next one, 128. Okay, this is not correct order. Okay. After attempt by Moseley's periodic table, okay, the scientist Rutherford discovered that the nucleus of the atom contains positively charged protons. Okay, and scientist Moseley discovered after studying the X-ray that the periodic properties of elements are related to their atomic number but not their atomic weights, as Mendeleev believed. Okay, so Mendeleev depended on all of these conclusions and modified on Mendeleev's table. So the most important modifications of Moseley on Mendeleev's table, the first one, he arranged elements in ascending order according to their atomic number. Okay, which where the number of each element increases by 1. Okay, I will explain this point. So, for example, here, this is a sodium atom, 11. magnesium. So sodium here, the atomic number, it's 11. So the next element comes after the sodium, its atomic number, it must be 12. Okay, not 11 and half, not 11.7. Okay, this is wrong. So the atomic number increase by 1. Okay. The second two, he added inert gases, which includes helium, neon, argon, krypton, xenon, radon. Okay. He specified a place below the table for lanthanides and actinides elements. Okay, finally, modern periodic table. So the scientists discovered main energy levels, okay, which are K, L, M, N, O, P, Q. 7 main energy levels and the heaviest atoms known till now. So after the scientists had discovered that each atoms had energy levels, and each main levels contains a definite number of other levels known as sub-energy levels, which are S, B, D, and F. Okay, so they reclassified the elements in the table known as modern periodic table. So in modern periodic table, the elements are classified according to the first one, their atomic numbers, 2, the energy, the way of filling the energy sublevels with electrons. Okay, again, in modern periodic table, the elements are classified according to their atomic number, the way of filling the energy sublevels with electrons. Okay. Here, let's move on to the modern periodic table. So the number of known elements in the modern periodic table till now is 118. 118. 92 are available on the Earth's crafts, while the rest are prepared by scientists in the labs, okay, or artificially. So we can summarize the attempts of elements classification as following. Attempts of elements classification. Mendeleev's, the first one, Mendeleev's periodic table elements are classified in ascending order according to their atomic weights. But Moseley's periodic table elements are classified in ascending order according to their, yes, atomic numbers. Finally, modern periodic table, the elements are classified in ascending order according to their atomic numbers. Number 2, the way of filling the energy sublevels with electrons. And here, as you can see, this is the model of modern periodic table. Okay, the modern periodic table consists of 7 horizontal periods, 7 horizontal periods, and 18 vertical groups. 18 vertical groups. Again, the modern periodic table consists of 7 horizontal rows or periods and 18 vertical groups. Okay, and also the modern periodic table consists of 4 blocks, which are S block, P block, D block, and F block. Okay, the first block is S block. S block. So the position of S block, they are located in the left side in the modern periodic table, okay? And the arrangement in two groups, 1A and 2A, okay? But pay attention, S block and B block take letter A, take letter A, okay? So in the modern periodic table, we have two numbering, okay? Normal numbering, which are 1A, 2A, 3A, 4A, 5A, and new number, which is 1, 2, 3, 4, 5, 6, 7 till 18, okay? So again, S block, they are located on the left side of the periodic table, and the arrangement in two groups, 1A and 2A. B block, B block, they are located on the right side in the modern periodic table, and the arrangement in six groups start from 3A, 4A, 5A, 6A, 7A, and not 8A. No, this is wrong. But the group here called zero group, okay? Zero group, which are noble gases, okay? The third one, D block elements. D block elements. So D block elements, they are located in the middle in the modern periodic table, okay? And they have another name called transition elements. Transition elements, okay? And they appear start from period 4, okay? Look at the modern periodic table here. Period 1 not appear, okay? Period 2, period 3, period 4, okay? They are appear start from period 4, okay? And the arrangement in 10 groups, 10 groups. Start from 3B, 4B, 5B, 6B, 7B, except group 8 not take letter B, okay? And they continue 1B, 2B. So they appear starting from period 4. Finally, F block elements, and they are located below the modern periodic table, and they consist of two series, so which are lanthanides elements and actinides elements, okay? Lanthanides elements and actinides elements. Okay, and now let's study how to locate the position of elements in the modern periodic table, okay? It's possible to determine the location of elements of group A, okay, in the modern periodic table by knowing their atomic numbers and vice versa, where the element period number equals the number of energy levels occupied by electrons in the atom. So the element group number equals the number of electrons in the outermost energy levels, okay? Let's take an example to explain this point. Example here, locate the position of each the following elements in the modern periodic table, okay? Calcium 18, 20, neon 10, phosphorus 15, okay? Calcium, so the electronic configuration here, 2882. Okay, the question here, how many energy levels are there? Okay, 4. So 4 here express to or indicate to this elements lies in period 4. Lies in period 4. Okay? Here, an energy. How many electrons in the outermost energy level? 2. So this element lies in located in group 2A. Group 2A. Okay. Another example. Neon 10. Neon 10. The electronic configuration here 2 8. Okay. So the question, how many energy levels are there? 2. So this element located in the period 2. Here, how many electrons? How many electrons in outermost energy level? 8. So what does it mean? That's mean the element here located in group 0, not group 8A. Okay? The final elements, okay, locate the position. Phosphorus is located in okay, so the question here, how many energy levels are there? Okay, 3 main energy levels. So this element located in period 3. Okay, look at the outermost energy level. How many electrons occupied in the outermost energy level? So 5. So this element located in group 5A. Okay, that's clear. Finally, how to calculate the atomic number of an element in the modern periodic table. Example, calculate the atomic number of each of the following elements. 1. Element X exists in the 4th period and in group 1A. Okay. 4th period here means the element X contain 4 main energy levels. Okay, like that. K, L, M, N. Okay. And here the example give me the element X exists in group 1A. Okay. So I must put here an outermost energy level, okay, 1 electron, and the rest of main energy level, okay, filled as you learning. Okay, 2 8 8 1. Okay, summation there, 2 plus 8 plus 8 plus 1 equals 90. So the atomic number of element X equals 90. The second example, element Y exists in the 3rd period and in group 7A. Okay, so 3rd period here, okay, means that element Y contains 3 main energy levels, K, L, M. Okay, group 7A, that's mean an outermost energy levels occupied with 7 electrons. Okay, and here 2 8. Okay, summation there, 2 plus 8 plus 7, 17. So the element Y, the atomic number of element Y equals 17. Okay, so this is end of lesson 1. Okay, thank you for listening.